Okay, let's talk about longest repeating character replacement. This one comes up all the time at places like Google, Uber, Amazon, and there's a reason for that. On the surface it looks straightforward, right? But the difference between a passable answer and a great one. That's what we are going to dig into today. Okay, so here's what the problem is asking. You are given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English letter. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. Now let's make this concrete with an example. Given s is equal to above, k is equal to 2, the expected output is 4, replace the two a's with bs or vice versa to get bbbb or aa. Alright, so a naive approach might just check every possibility, but we can do way better than that. Let me walk you through this visually because I think it makes the whole approach obvious. Let's look at the example. Given s is equal to above, k is equal to 2, the expected output is 4, replace the two a's with bs or vice versa to get bbbb or aa. And notice what's happening. Maintain a window that expands and contracts to track the optimal range. That right there is the core idea. Everything else is just details. Now here's where it gets interesting. Maintain a window that expands and contracts to track the optimal range. Think about what that means for our approach. First, use a sliding window. The window is valid when window size, count of most frequent char, happy smiley k. Then, track the count of the most frequent character in the current window to determine if you need to shrink. Next, parse the input and identify edge cases. And finally, apply the sliding window technique. That's it. Simple once you see it, but powerful. Okay, time to code this up. And I want you to notice how short and clean this ends up being. We start by defining our function that takes self, s, k. Then we loop through the input, and at each element we are asking, does this give us what we need? At each step we check our condition, and the moment we find the answer, we return it right away. No need to keep going. Notice the two pointers, left and right, working toward each other. That's the classic pattern. Simple, right? The hard part was the thinking. The code is the easy part. Alright, let's talk about how fast this is. Time complexity, O(n). Why? We make a single pass through the input. Space, O(1), because we use only a constant amount of extra space. And here's the cool part. This is a go-to problem at Google, Uber, Amazon, and the pattern you just learned, the sliding window pattern, shows up in problems like longest substring without repeating characters and minimum window substring. So you didn't just learn one solution, you learned a technique. If this was helpful, subscribe because every video in this series builds on the last.